me introduce you to the activities related to task 6.7 in the EOSC-Pillar project. And let's speak about seismology. Seismology is among some of the most advanced and well-organized disciplines considering FAIR principles. With an international federation, FDSN, providing guidelines and formal specifications for data formats and provisioning systems in order to foster the standardization of data search, selection and retrieval, the community was able to develop an interoperable ecosystem of software clients and users. But in the last years, some game-changing technologies have been developed, and the demand for these new technologies is advancing fast. This includes deployments of huge number of easy-to-install geophones and also fiber optic-based technologies, called DAS, that can be used as to measure ground motion using the so-called distributed acoustic sensing technique with existing underground fiber optic cables. You know, they are present everywhere in the cities, but also in the seafloor. However, the price to pay is the huge amount of data being generated. How to provide long-term storage for them, how to make following not only the FAIR principles, but also the community standard. This starts to show their great potential in providing quality data with a wide spectrum of applications ranging from tsunami early warning to infrastructure monitoring. Some of these techniques allow to image the internal structure of faults with an unprecedented resolution, to infer creeping processes at sub-micrometer step, or to provide a global network of real-time data for ocean climate and sea level monitoring. Just look into the figure. You see above the resolution with 12 of the usual seismic stations, and below what you get with only a small part of the resolution from a fiber optic cable. Unbelievable, isn't it? With the devices available today, we estimate a potential generation of 50 petabytes per year, but the price for these equipments are getting more affordable, so we expect a large increment in the data flow to any data center. Take a look at the archival rate in a full year of 3 of the most important data centers today, and how much space you need to store only one experiment using fibers. What we have already achieved within this task is the collaboration between 3 of the most important seismological data centers at the global level to define guidelines to mainstream this new type of datasets. The results achieved in the last 2 years of collaboration have been published in a high impact factor journal, and a full session in one of the most important conferences of Europe was accepted to further discuss these topics. We also provided the implementation of a software package called DAS Tools to standardize these new datasets before archiving them in any seismological data center, reducing the storage space needed and allowing different formats to ease the life of the researchers working with this data. The software also implements the community standard data provisioning services on top of the non-standard data format. With this, we are making petabytes of new attractive and valuable data fair.